My brother just had a vasectomy and the surgeon told him his scrotum was outstanding. He's very proud
Because
of
it was
that.
upright or because...
Not literally outstanding, I don't think. I think it's
It
just...
looked like a hamburger.
Just
I hate to say it, this could be one of the trailers.
go for it.
Our final round is free for all, a fact on whatever topic you like. Let's kick off with Jason.
So, as you might have heard so far, I'm quite a fan of Einstein. So, E equals mc squared is probably the most famous equation in his arsenal, possibly in the world. But what does it actually mean? It means roughly that I have the equivalent of 73,000 nuclear bombs stored within my body. Now, here's how to explain why. I weigh roughly 71 kilos on a good day, usually post-poo, about 71.5 beforehand. If you were to convert all the matter inside me into energy, what would happen? So, energy equals mass times the speed of light squared, speed of light being 300 million metres per second. You square that, you get an extremely large number in a vacuum. If you were to convert me into energy in a vacuum, where the speed of light would be roughly 300 million metres per second squared, no, it wouldn't. The speed of light would be 300 million metres per second. Then you square it in your formula. Then you multiply it by the 71 kilos of me. You get approximately 6.4 times 10 to the 18 joules, which is 6.4 septillion joules, which is a lot. So to contextualise that, that's about the same amount of energy as in a 1.5 million kiloton explosion. The bomb that destroyed Nagasaki was approximately 21 kilotons. So the amount of energy stored within my body, were you to convert me into energy, would be 73,000 nuclear weapons. Literally, boom.
I really like that fact as well.
Well, let's not declare me winner yet.
We're not going to declare you winner yet. But, well, for a start, I want to know how Jamie Oliver feels about this, how many number of joules. But also, what I really, really, really wanted you to do, and I hoped you'd have it in your research, would be convert that into the Duracell bunny.
Can only apologise.
It's okay.
Well, hold up. We're talking joules to watts, right?
A watt is a joule per second.
Precisely.
Yes.
So, over a time period, you would be able to convert this to watts,
Yeah.
root it.
Well, that sounds like a lot of effort though, doesn't
It
it?
does. Plus, we don't have either resistance or at what speed it's moving, thus the current, so therefore you couldn't translate it into volts.
So this is a no then? Just
Yeah,
it sounded like a no.
This is going to get more complicated than we've got time or inclination for.
I was going to say, if anyone wants to do this for the next time you're on,
So how many batteries worth of energy that is?
yeah, like how long would I don't know, some kind of standard unit, I don't know, maybe an MP3 player or a Walkman or a remote or something.
You're hosting. Like, send this out to your audience.
Yeah, okay, guys, how
are
many
geeks out there.
how many batteries worth of power are we going to get from one, Jason? And how long is that going to run?
An electric toothbrush.
An electric toothbrush.
Send your results to...
The comment section.
the comment section underneath YouTube. So my fact is that the event horizon of a black hole,
I'm liking the way this is going.
which is the point at which not even light can escape it, it's kind of the boundary of supersuction for a black hole. If you hit that point, if you're light, you're going in, gives off a faint glow. So I was originally had this down for my poetic justice. Yeah, as matter accelerates towards a black hole, as it passes the event horizon, things like gases and various different materials give off chemical reactions at this specific point that give off a faint glow, which is how you can often spot things like black holes, because you think black hole, how am I going to spot that, especially against black space and black everything else. So a lot of the ways they often spot these kind of things is by spotting the glow from the event horizon of a black hole, which is strange because light can't escape past the point of an event horizon. Anyway, I just find that quite interesting.
Quite like that.
But I mean, that makes sense. The bigger the pull, the faster it's going to pull things in. I mean, consider asteroids and shit like this. That we get bombarded with these, and we perceive things like shooting stars. when actually half of these are hitting the ground or burning up in atmosphere somewhere.
Yeah.
Now, why wouldn't the same be true of something with a much denser and much stronger gravitational pull? You'd see shit going towards this. You just wouldn't see it once it got past the point at which it blacks it all out.
Yeah.
Exactly. They're some of the brightest objects out there. The accretion disks surrounding black holes. So everything spins in, gets faster and faster and faster, friction, glow, explosions and whatnot.
Yeah.
Boom.
Interesting stuff.
Boom.
I wish I was going to say, I wish I'd had more time to read up about it before I actually did that one. That was one of my emergency facts.
Read A Brief History of Time.
I'd quite like to, actually. There are quite a lot of flaws.
It will give. Yeah, it's not perfect, but it will give you a nosebleed.
Okay.
You just have to think so hard.
Yeah, I was going to say his mistakes are kind of our nosebleeds. It's a nice contextualizer. So Dave, what have you got for us?
Okay, so given we're still on the spacey subject, the sun weighs 1.989 times 10 to the 27 tons. That's approximately 1.9 billion tons. The surface temperature burns at about 5,500 degrees Celsius.
It's hot.
Very fucking hot. But the weird shit is, if you took the same weight of bananas and chucked that into space, it would radiate the same amount of heat as the sun. This is because the heat is generated due to the pressures, or at least this is because the pressures caused by the gravity acting on these bananas would generate heat. Because the bananas wouldn't cause the fusion reaction that hydrogen generates, they would eventually cool down or burn out. So it wouldn't last long, but we would still experience, for a small amount of time, the same energy output as the sun.
Banana sun.
And we'd be left with a toasty, delicious, banana-y sun.
Yeah, right.
Eternal pudding.
Just get like a sea of, I don't know, treacle. Or, yeah, right?
Because I was going to say, because I thought it might be to do with like their radioactivity. They might have had some kind of fusion thing en masse. Because
In fact.
Yeah, because bananas are radioactive. Same as Brazil nuts. Which is
Bananas in space.
Yeah, interestingly, if the sun were to suddenly collapse into a black hole, we would all be killed, right? Well, we'd get cold. But the Earth would still orbit in exactly the same fashion. Because
so everyone would die, but it would do the same thing without us.
Yes, the Earth would still carry on. Same amount of mass, same gravitational pull.
Nice. I hadn't.
So essentially, life is meaningless.
A banana sun is more meaningless.
No, I've never. That's really interesting because I've always considered the concept of black holes to have this insane pulling power, but it's all based down to its gravitation.
It's because they're so massive.
It would shrink insanely small.
Yep.
Because we have a relatively small star.
Yep.
Good old soul.
So, are we going to go with Jason and his human Duracell bunny? Are we going to go with my Event Horizon Glow? Or are we going to go with Dave's Banana Supernova? Jason.
Much as I love a black hole, that's a great fact. Banana sun.
Banana sun.
Always banana sun.
Dave, who are you going to go with?
Don't take it personally, but I'm liking the black hole Event Horizon.
This is really quite unfortunate.
Are you about to have to choose a winner?
No, I'm not at all.
Do I have to vote for myself to make this easy?
No, because I want to vote for Jason.
So wow. we're all there.
So let's just do a quick count. So, that is unbelievable.
Woo!
Okay, so...
What about you? Where are you on this?
I won 2 rounds.
But there's only been 5 rounds.
Yeah, and you've got 4 and he's got 3, so do the math on that one.
And you've got 2.
Astrophysics boy. Yes.
So out of 5 rounds,
So Dave
Somehow there have been...
Dave won the first, the second, and the fifth round. You won the second, the third, the fourth, and the fifth round.
Oh, we're getting points for draws.
Okay.
Yep.
Sorry, repeat your paper shuffling, because I think there's a place for you on the news.
Do you reckon?
Yeah.
I think we need the mic to be a little bit closer for this.
Oh, there's a really cool fact.
Can you do that, but with a roundup? Like,
there's a really cool fact. No, Star Trek. You know the original series of Star Trek?
I know it well.
Oh, do you know the fact I'm telling you?
No. What?
The sound of the doors opening and closing on Star Trek was them pulling paper out and pushing it into an envelope. That was literally all it was.
Mind
blown, right? Amazing. Foley artists are fantastic.
you know how many of these facts that I was sifting through, especially when it came to the film and TV, that I was just like, how physicsy is this?
Yeah.
It's actually, they predicted the future on like a dozen different occasions. Self-opening doors.
One of the ones I really wanted to mention last week was the fact that the ancient Greeks invented self-opening doors. The library at Alexandria had automatic doors.
How?
They're powered by steam.
What?
Yeah, no shit. I really don't know how specifically it worked, but they had plumbed showers and various different things. So that means the winner for our final round is everyone, and which makes the absolute winner of this episode, Jason. Well done, Jason. Yay! Thanks to all of you who've joined us for our fourth episode of A Matter of Fact. If you like us, you can join us and follow us on Facebook at facebook.com/A Matter of Fact podcast, and of course listen to us on YouTube. It's with great pleasure that I say thank you to Jason Richardson and Dave Cordingley for joining me.
Thank you.
I've been Kirby Rawstorn. Goodbye.